last problem we're working on together, all right, in chapter 3, section 4, linear programming, number 6. I'm going to highlight this one in blue, this one in red, this one in green, and this one in magenta, but I'm not going to be doing shading all together at the same time, because that would just make this look ridiculous. So, this one's kind of tricky. Why? Because we have standard form in both. Our first sets of inequalities are in standard form, and we need to change them to what?
Y equals mx plus b.
Right, exactly. Slope-intercept, right? All right, less than or equal to 2. Okay. Now, before we get started, it's always easier to know how to go somewhere to have some directions, right? So right now, you guys notice right here that in front of this one we have a positive, but in front of this one we have a negative in front of the y's. So automatically you know that when you solve for y here, when you solve for y, is this inequality going to change on this one? No. So just remember, this is going to be a y is greater than or equal to. But if I have a negative in front of here, what am I eventually going to have to do? Multiply or divide by a negative, and what's going to happen to my sign? It's going to change. So it's going to change from less than or equal to greater than or equal to. So you kind of need to know that before you start working it. You kind of know where you're going before you get there. All right? Now, let's solve this one first. To get rid of the 2x right here, you could either just throw it across and make it negative, or you could subtract 2x from both sides. You're left with 3y is greater than or equal to negative 2x plus 6. Notice all I did was just move that up front. Okay? And then just keep the positive 6 right there. Then divide everything by a 3. And y is greater than or equal to negative 2/3 x plus 2, which is a very easy linear inequality to graph because we have a clear slope. Negative 2/3. We have a very clear y-intercept. That's a positive 2. This lets me know I need to go down 2 and 3 units. So when you have this right here, what kind of line are we going to have with a greater than or equal to sign? We're going to have a solid line, and we're going to eventually shade above it. Okay? So let's plot our y-intercept first. Right here at a positive 2, there's my y-intercept. Plot it right there. Once you have your y-intercept plotted, then apply your slope. We have a down 2 to the right 3 ratio. That's our rise to run. Down 2 over 3, put a point. Down 2 over 3, put a point. If you run out of room, you can also go up 2 and over 3 to the left. Another strategy. Make a nice solid line. And eventually, where are you going to shade? You're going to shade everywhere above the line, but I'm not going to do it right now. I'm going to wait till the last part. Just know that's where it's going to be shaded. All right, have the blue line done. Now we're going to move over to the red line. You get to do the exact same thing. I'm going to do this a little bit differently. I'm just going to say 2x. I'm going to move you way over here. What does that become? You throw something across an inequality sign. Yeah, so that becomes a minus 2x. So here's what we have left. We've got a negative y is less than or equal to a negative 2x plus a 2. I just moved it up front. Now, you can divide or you can multiply by a negative, right? So I'm just going to multiply everything by a negative. If we do that, we get y. What happens to the inequality sign? It flips. All right? Negative times a negative is a positive. Negative times a positive is a negative. We have a slope and a y-intercept here. Our slope is 2, but what does that mean? It means we have a what to what ratio? We have a 2 to 1 ratio, which means we have to go up 2 units and over 1 unit, but our y-intercept is clearly at a negative 2. All right? So this, just like this one, was really easy to graph once it was changed to slope-intercept form. This one is also very easy to graph. We're going to graph this one right now. Where are we going to start, everybody? We're going to start where? Well, no. Negative 2, right here. So we're going to start right here at the negative 2 on the y-axis. That's our y-intercept. And then we're going to apply our slope up 2. Up 2. All right? And make the line going through all those points. And And where are we going to shade this line? Greater than or what? Greater than or equal to. So this would actually, if we wanted to, all of this right here would be shaded. But I'm not going to shade all of it right now. Because where was the blue shaded? Everywhere. So does everybody see where the solution region or the feasible region is right now so far? It's right in this area. But I'm not going to do it just yet. Save it to the end. Now we have 2 more to go. And we're done. X is greater than or equal to 0, and y is greater than or equal to 0. I'm going to make these lines a little bit thicker, because it's kind of hard to see on this graph. So we have x is greater than or equal to 0 right there. Where would I shade? Everywhere to the right. And then we have y is greater than or equal to 0. Where would I shade? Everywhere up. So let's think about where we're going to be. When everything's shaded, our feasible region, or our solution region, will be right here. Do you see how that's unbounded, everybody? That is unbounded, which means we're not going to have a maximum. You will have a minimum in this problem, but you will not have a maximum. Now here are my ordered pairs that I have to worry about. There's one of my vertices right there. And here's another one of my vertices right here. So I'm going to write the word vertices. Okay? One of them is easy to find, one of them is slightly more difficult. Our easy vertice right here is at a 0, 2. So write 0, 2. What 2 lines are intersecting that I need to find for this one? I have the blue line and the red line. So let me write the equation for the blue line. In y1, I'm going to write y1 is going to equal negative 2/3 x plus 2. And in my graphing calculator, I'm going to make y2 equal to 2x minus 2. So in your graphing calculators, you can type those in. All right, we've solved by hand. We've solved these by hand. We're just making this a little bit easier since you have a lot to do on this problem. So take those 2 equations and type them in exactly as they appear in the graphing calculator. y1, go up here, negative 2 divided by 3x plus 2. 2x minus 2. There's my blue line, there's my red line. I hit the graph button. I see clearly where they cross. And then once again, we hit second, trace, number 5, enter, enter, enter. And it gives us our beautiful point of intersection right here. There's the point, it intersects. And it looks like it is at 1.5, 1. So I'm going to go down here on my paper and put 1.5, 1. If you would have written 3 halves, 1, I totally accept it. All right? Now, we have our vertices. So now we have to use our function. I'm going to rewrite the function right here so you can see it. F of x, y equals x plus 4y plus 3. So we only have 2 vertices. So put an open parentheses for my x, open parentheses for my y, and then add 3 at the end. Now, once again, what did I say there was not going to be? There was not going to be a maximum because it's unbounded. So if you have it's unbounded going up, there's no maximum. It's unbounded going south, that means there's no minimum. All right? All right, here we go. That's a 0. That's a 2. That's a 1.5. That's a 1. 8 plus 3 gets us to an 11. And let's see, that's a 4, that's 7. That gets us to what? 8.5. And I said there was what? There was no maximum, right? To put maximum, I'm going to put min. Yeah. And our minimum ends up being 8.5. Now listen, tomorrow we're going to be doing a review over the 6 weeks. And this is the type of stuff you're going to have to know how to do. We're going to review how to do it once again. All right? So hopefully this video will be helpful. You can go through all the steps. You can pause, read, go back, watch it again if you need to. You can mute me and just watch the math, or put up with me and listen. Have a wonderful day.